So this question looks more difficult than it really is. When you see a complex circuit like this, it's probably Kirchoff's first and second laws that you'll need to apply. So it says the cells in the circuit shown in the figure below have zero internal resistance. Currents are in the directions shown by the arrows. R1 is a variable resistor with resistance that varies between 0 and 10 ohms. Write down the relationship between I1, I2, and I3. Well, that's not difficult. I3 is basically I1 plus I2. The currents that go into a point equals the current that comes out. That is essentially conservation of charge. Next question. R1 is adjusted until it has a value of 0 ohms. State the potential difference across R3. Well, Kirchhoff's second law says voltage that goes into a loop equals voltage that comes out. So the EMF is 10 volts at V1. That means the voltage that comes out, which is the potential difference, is also 10 volts because nothing has been dropped at R1. Okay, next question says determine the current I2. So I2 is in the second loop. And if you have 10 volts sitting across R3, then you've got 2 volts left for any coulomb that travels in that loop on the right to spend, if you like, at R2. So 2 volts divided by 10 ohms will give you a current of 0.2 amps. Lastly, state and explain what happens to the potential difference of R2 as the resistance of R1 is gradually increased from 0. So if you have 10 volts of PD across R3 and you increase R1 from 0 ohms to something, then more voltage or more PD will be dropped across R1. That will mean there's less energy left at R3, therefore less voltage will be dropped at R3. Now, if you look onto the right, onto the second loop, that will mean VR2 will go up if VR3 has gone down because there's more voltage left out of the 12 volts to be dropped at R2. Another way I can look at it is I can put numbers onto it. If we imagine R1 has a voltage of 1 volt, that would mean there's only 9 volts left to be dropped at R3. Then I would have 3 volts to drop at R2 because 12 volts was my EMF in that second loop on the right.